So what is a switch? A switch is a network device which works with layer 2 frames. Frames carry data from host A to host B with the help of MAC addresses, and the MAC address is a hard-coded physical address of a network interface card. A MAC address is uniquely identifying the network interface card of a specific device. It can be a switch, router, firewall, host, any device which have networking capabilities. And every device with networking capabilities must have a MAC address in order to participate in data transfer. A MAC address is a 48 bytes address where the first 24 bytes are the organization identifier. Let's say Juniper will have its organization identifier, and it will manufacture the network interface cards for their devices using some internal rules for assigning the MAC addresses to the NICs. A frame will have the destination MAC, source MAC, VLAN, and the payload. These are the most important fields of a frame, and the payload is representing basically the data which is being carried. Also, a switch works with VLANs. A VLAN is a logical network separator which is enabling the switch to have multiple networks defined and separated. For example, when we are configuring VLANs, we want that PCs from VLAN 10 to communicate with other PCs from VLAN 10 and to not be able to communicate with other PCs from, let's say, the financial department and maybe others. So on switches with VLANs, we should also specify trunk and access ports. Trunk ports will carry multiple VLANs, and usually these trunk ports are configured between switches, and in some cases the trunk ports might be configured between servers which are carrying multiple VLANs, or maybe, let's say, on which data is separated by multiple VLANs. And also trunk ports are also referred as tagged ports. And we can have access ports, which are ports that are connecting a PC to a switch, let's say. And access ports are called untagged ports, and we can have a single VLAN configured on that port. So let's jump to the lab and see all these ports in action. We have this topology, and as you can see, I have recreated the topology that is on my slides. So these are the access ports, and this is the trunk port. We'll start a capture here, and we will go to PC1 in VLAN 10, and we'll try to ping PC4 in VLAN 10. So the ping is working, and let's see our capture. So this is the source, this is the destination. If we are checking our capture, And if we go to the Ethernet, we will not see a VLAN tag here. And as I showed you in my previous slides, the most important fields in the Ethernet header are the destination MAC and the source MAC. And also other options. Let's make a capture here. And let's run the ping again. If we'll go to our capture and we check here, we can see that the traffic which passed on the trunk port had a VLAN tag of 10. So in fact, what is happening here? When PC1 will send its traffic to PC4, the traffic will arrive here untagged. It would be the switch responsibility to add the VLAN tag on the for the traffic received on the access port. It will add the VLAN tag. It will pass the traffic via the trunk port, and the trunk port, which is a tagged port, will check the VLAN tag on the frame and will send it to the next switch. When the traffic will arrive here and will be sent to PC4, the VLAN tag will be removed and the traffic will be delivered to PC4. Okay, so now let's try and ping PC2 from PC1. So as you can see, PC1 have this IP address. Let's copy it. And let's ping PC2. As you can see, we'll have the error no gateway found. And let me check if I configured the gateway. No, I didn't. IP address 10.10.10.1/24. And the thing is that we don't have a gateway because we don't have a router here. But what can we do is go here and this should show configuration. Set VLANs 1 L3 interface will create IRB 10. So set interface IRB 10 family inet address 10.10.10.3/24. Let's commit this. Go back to PC 10, PC1 with on VLAN 10 and add the default gateway here, which is this one. And let's ping the default gateway. The ping is working, which means that now we can ping PC2 on VLAN 20. And as you can see, the traffic will not reach PC2 on VLAN 20. And our logical separation with VLANs is working correctly. Also, one interesting thing that we can have ports without any configuration. And I am introducing the native VLAN terminology, which is a option that can be configured on the trunk port. and it is this one. This is the trunk port. As you can see, I have listed the VLANs which are allowed to pass on this interface, and I also specified the native VLAN, and I added the VLAN here. So if I go on PC3 and I will try to ping PC6, which also doesn't have any VLAN configured on XE003 interface, and if I ping it, the ping will work. And what will happen if we'll check our capture from the trunk port? If we'll check here, we cannot see any VLAN tag in comparison with this one, where we can see the VLAN tag here, which is the VLAN 10, and here we cannot see. So this means that we can have also untagged traffic on the tagged port, and we can use the native VLAN to achieve this. Thank you for watching. I hope that this video was what you were looking for, and I will see you in the next one.